Welcome back, everyone, to the Mastering VCF Series, episode number 5, vSphere, the compute foundation of VMware Cloud Foundation. In the previous episode number 4, we explored how VMware Cloud Foundation organizes infrastructure. We discussed how workload domains operate and how the management domain controls the entire environment. Today, we go deeper, much deeper, because before automation, before cloud operations, before Kubernetes and AI workloads, there was one revolutionary technology that changed enterprise infrastructure forever. And that technology was vSphere. And if you truly understand vSphere, you don't just understand virtualization, you understand the foundation of modern cloud infrastructure. So, in this episode, we are going to understand what vSphere actually does, how ESXi abstracts compute, how your compute abstraction works, how cluster create cloud scalability, and most importantly, we will understand why vSphere became the compute engine behind VMware Cloud Foundation. But before we start, guys, a quick introduction about me. I am Neeraj Mantri, VMware and Cloud Security Architect with 19 years of experience in virtualization, data center, cloud, and security solutions. So now, before we go and talk about vSphere, which is the compute foundation of VCF, let's reconnect everything what we learned in episode number 4. So, guys who are directly watching out episode number 5, we would strongly recommend you and request you to please watch out the previous 4 episode of Mastering VCF series before you join us on the episode number 5. You can find the link on the YouTube description. So, in episode number 4, we learn that VCF organizes infrastructure into domains. And that is where we talked about management domain and workload domain in the episode number 4. So on the left, if you see that, this is our management domain. Now, the management domain is the one where your vCenter server, your SDDC manager, your NSX managers, lifecycle automation, and centralized operation exist. So this management domain is actually considered to be brain of the VCF infrastructure. And on the right, we discussed about workload domain. Workload domain where we run our business applications and services. Now, workload domain have a different environments designed for Kubernetes, databases, VDI workloads, AI ML workloads, and enterprise business application. So now think carefully. Now think carefully and see that all these workload domains, what we really talked about it, it needs compute to run your Kubernetes workloads, to run your AI ML workloads, to run your VDI workloads. It required compute, a real compute. And when we talk about compute, we talked about CPU, memory, storage, and networking. So the real question comes, what actually powers these workloads? What actually power these workloads which are going to run in my workload domain? And the answer is none other than our vSphere. But to understand why vSphere became revolutionary technology, we first need to understand the world before virtualization existed. So now let me take back to the world before VMware introduced the concept of virtual machines. Before virtualization, enterprise infrastructure had a massive problem. And what was that enterprise compute problem? The problem was that every application needed its own physical server. It's a one-to-one mapping between application and the server where this application is running, which means one application, you require one physical machine. That means Exchange server, if you have application like Exchange server, it would require dedicated hardware. If you have a database application, it would require dedicated hardware. If you have web application, it would require another dedicated physical server, which means that if you see everything was tightly coupled to the hardware because every application is tightly coupled to the hardware. It brings us to the problem of wasting our resource utilization, wastage of resources. Because as you could see that there is a one application is running on one physical server, which means that most of the servers were using only 10 to 20% of their resource capability, which means majority of the time the resources were staying idle. So wasted resources was one of the bigger concern for the enterprise. Every server was running in their own silos. Every application lives in its own silo with no resource sharing. And then your every single team is owning their own separate infrastructure. Server team will have their own separate infrastructure, network storage. Everyone was having their own separate infrastructure. And that siloed infrastructure always adds up to the scalability challenges because scaling means buying new hardware. And if you are buying a new hardware, you have to rack it, you have to stack it, you have to cable it. And that is require a lot of time, right? Which means if you need more performance, you need more hardware. But if you need more hardware, you have to rack it, cable it, stack it, configure it. And you have to wait for weeks. And worst of all, the biggest challenge with the traditional hardware based approach was that downtime risk. If my one physical server failed, the application which is running on that server will also fail. This was not cloud, this was hardware dependency. And enterprises realized something very important. Enterprise in early those days, they realized something very important that they were buying infrastructure, they were buying hundreds of servers, right? But they were not utilizing it, those servers. And because of the complexity of the underlying hardware, the entire infrastructure was kind of rigid. It was slow, hardware dependent, and it was very difficult to scale. So these were another certain set of challenges what enterprise was really facing it. So before virtualization, applications depended. directly on hardware. And then what happened suddenly? And then the virtualization changed everything. This moment when virtualization changed the compute forever, this moment was one of the biggest turning point in enterprise infrastructure history. Traditional world, as we have discussed, one application, one server, and that was imposing all these set of challenges. But VMware introduced a revolutionary idea. VMware introduced a revolutionary idea which changed compute forever. What if multiple isolated workloads could safely share the same physical hardware? What if I could run every single application in an isolated environment into a single physical hardware? And that idea became virtualization. And the brain behind this virtualization is our VMware ESXi. As you could see in this particular slide, we have one physical server on top of which the ESXi hypervisor is running. And this hypervisor is making it possible for us to run VM 01, 02, 03, 04, 05, multiple VMs to run on a single hardware, but making sure that they are running in an isolated environment, same as physical hardware. That's the revolutionary technology what industry have witnessed. And suddenly, because of virtualization, your hardware utilization improve, your scalability improve, your availability improve, and most importantly, you can manage this hundreds of thousands of virtual machines from a single pane of glass, which means no operational silos. And that's how your operational efficiency also improves. Because you could see that it gives you hardware abstraction, resource sharing, easy to scale because virtual machine is a construct, high availability, DRS kind of capability. This virtualization provides us. And most importantly, stronger isolation. So this was no longer just server consolidation. This was compute abstraction. And this compute abstraction, or so-called virtualization, became the beginning of modern cloud infrastructure. You know, let's understand what exactly is vSphere. Is vSphere is only ESXi, or vSphere is it only virtualization, or is it much bigger than that? So let's go and check out and understand what exactly this vSphere is. And this particular slide, what is vSphere, is probably one of the most important slides in this entire because many engineers think vSphere is equal to ESXi, but the answer is no, because ESXi is only one component, as you could see, of this entire stack, where your vSphere is an entire compute platform. It's a compute platform. What do you see that? At the bottom, if you see in this architecture, we have a physical servers. This is our physical infrastructure to called our physical layer. In this physical layer, we would be having a real servers, real CPU, real memory, and real storage. So that is our physical layer, physical infrastructure. Above that, we have ESXi hypervisor. Now, ESXi hypervisor is our hypervisor layer. This hypervisor layer abstracts hardware and it enables secure, efficient workload execution. And this hypervisor is the layer where abstraction happens. Then we have a next layer in this architecture, in this platform, is virtual machines. Virtual machines, we hope everybody knows that virtual machine provides it help us to run multiple isolated workloads with a full abstraction and portability. On top of that, we have clusters, aggregated pool of resources. And we all know that cluster aggregates your multiple host resources into a single pool of compute resources. So that is what our cluster is. Then the next layer we have management layer. One of the most critical layer is a vCenter management. vCenter server is also provides the single pane of glass, which we all know, which gives you a complete end-to-end visibility, automation, and infrastructure control. So that is what is our vCenter, which gives you centralized management. And finally, we have a cloud infrastructure. This architecture transformed physical hardware into software-defined compute. So that's what, as you could see that, and we have already said that it's one of the most important slide where you could easily see that vSphere is a compute platform. And if you look at carefully at the operational advantages, it gives you centralized management. It gives you resource efficiency. It gives you high availability. It gives you security, isolation. It gives you elasticity, scalability, intelligent operations, and flexible and extensibility. And this is the exact reason why enterprises adopted VMware so aggressively. Because vSphere was not selling virtualization, it was selling operational transformation. And that's what vSphere is all about it. So now let's zoom into the most important component inside this vSphere platform, and that is our ESXi hypervisor. So let's zoom into our most important component inside this vSphere. ESXi. We hope everyone would be aware of ESXi. It is the compute engine behind VMware infrastructure, right? And this is the compute engine or our hypervisor, which allow us to run multiple applications in these virtual machines in an isolated manner. Now, this hypervisor installs directly on physical hardware. So this is your bare metal architecture. The workstation product, VMware Fusion product, you might have heard of it. Those are hosted architecture, but this ESXi is a bare metal architecture where this hypervisor installs directly on the physical hardware. So there is no traditional operating system underneath. which means because we are not relying on any traditional operating system, which means lower overhead. It gives you lower overhead, better performance, and enterprise grade stability. And that's what you could see. So now this ESXi hypervisor provides us compute or CPU abstraction. It gives you memory abstraction, it gives you storage abstraction, and the network abstraction as well, which means the VM does not directly interact with the physical hardware anymore. Because when we talk about abstraction, which means that these virtual machines are not talking to this hardware directly anymore. This is the hypervisor layer which actually tracks your CPU memory storage and networking. And that is where your ESXi hypervisor become the most intelligent broker or layer between your VM and the underlying hardware. Think about as an apartment building where you have one apartment and you have a multiple tenants residing in that same apartment where every tenant thinks that they have their own isolated flat or space. But we all know in the apartment culture, underneath the building infrastructure is shared, where multiple tenants might be having their own isolated space, but there is a shared infrastructure. That's a common building. And that's exactly what ESXi does. In this abstraction layer, what do you see that this abstraction layer is what enabled cloud computing to become possible. And that is the foundation of the modern cloud infrastructure as well. So as you could see that you have a physical hardware. Earlier, these applications were directly running on the physical hardware. But with the virtualization, we do see that there is a ESXi hypervisor, which is directly running on the physical dedicated hardware. And there are virtual machines, and within these virtual machines, which are software construct, and within that virtual machines, we are running those applications. And that is where we are talking about abstraction. And that is the reason why our modern cloud infrastructure become possible. And that's what we have discussed, that this ESXi hypervisor, you can consider this as an apartment culture, where you're hyper like an apartment, your manager sharing one building across many tenants. And that is what our hypervisor is doing it, where this hardware resources are being shared across all these VMs. And that's the beauty and intelligence of VMware. So if you guys are seeing infrastructure differently, that means you're no longer learning tools. You're started thinking like an architect. Now, if this series, guys, Mastering VCF Series from GoVMlab is really helping you understand VMware, the way enterprise actually deploy it, make sure to subscribe to GoVMlab channel. Please like, share, and subscribe to GoVMlab YouTube channel and keep supporting us because upcoming episodes will go much deeper into vSAN, NSX, VCF operations, VCF automation, designing, and enterprise architects. At GoVMlab, guys, our goal is very simple, not certification memorization, but we believe into real enterprise understanding. So please like, share, and subscribe to GoVMlab YouTube channel now and keep supporting us. Now, running virtual machine on one host is really powerful. We all have witnessed that. But enterprises need something much bigger. And that is what takes us to the next slide, our vCenter server. It's a one centralized control plane. vCenter server, this is where your virtualization became cloud operations. Your vCenter server gives you one control plane to manage hundreds of ESXi hosts and gives you a complete visibility. vCenter server introduces centralized management. Instead of managing one ESXi host at a time, imagine a world if we did not had, if we didn't have vCenter server, then how the world used to be, where you have the farms of hundreds of thousands of ESXi hosts, and you are managing them individually. So that is where vCenter server really help us out. Instead of managing one ESXi host at a time, VMware administrators could manage hundreds of thousands of hosts from a one control plane. And suddenly, because of one centralized control plane, we get and centralized visibility. We get automation, monitoring, orchestration, policy control, and the life cycle management. And that is where all visibility, automation, monitoring, orchestration, policy control became centralized. And this is where, if you see, we compare vCenter server to our airport traffic control. Same like we have taken the same example for the management domain as well, where you could see that imagine a world where hundreds of moving workloads, continuous monitoring, intelligent coordination, and at the same time making sure that no conflict is happening. And it gives you the complete visibility and the coordination. Without vCenter server, you had isolated hypervisors. With vCenter server, you have enterprise grade cloud operational model. So as you could see that your vCenter server transforms virtualization into cloud operations. But enterprises still had another challenge. And the challenge was that, okay, we understood there is a ESXi helping us to create multiple VMs. We understood there is a centralized control plane giving us a complete end-to-end visibility, automation, monitoring. But still, enterprise had another set of challenges. And one of the biggest challenge was what happens if one of my ESXi hosts fails. That's the next set of challenge enterprise was having it. And this is where infrastructure started behaving like a cloud. If you see, instead of individual, instead of individual ESXi hosts, what VMware did, we joined multiple ESXi hosts together into clusters. And suddenly, when we join multiple ESXi hosts together into clusters, now your CPU became pooled. Your memory became a pool of memory resources. Your storage became a pool of storage resources. And if you really see, that is the foundation of the modern cloud platform or the cloud. Because now, this clustering, my infrastructure became shared. And because resources were shared because all these resources being CPU, memory, storage, network, they were being shared. The VMs no longer depended on one physical server anymore. And that is where VMware introduced a feature called DRS, your distributed resource scheduler, right? So DRS is the feature which intelligently balances workload across host. So that is what your dynamic resource scheduling does it, where DRS automatically and intelligently balances workload across host, achieve optimal performance. And then we had another feature. We have another feature called high availability. If one ESXi host fails, VMs automatically restart on healthy hosts. Think about what this means for enterprises. Because now, because of the clustering, because of the resource pooling, infrastructure is no longer tied to hardware failures. Your applications survive hardware outages. And this was one of the biggest operational revolution in enterprise compute. In fact, VM mobility has been one of the biggest operational revolutionization or revolutions in enterprise compute, where VMs can be migrated seamlessly across ESXi host without causing any downtime. So zero downtime, zero maintenance, zero downtime, no application impact when you're doing hardware maintenance, and it gives you balanced performance. That's what the vMotion have done for us, right? So in short, if you really see that your clusters pulling multiple hosts together into a shared pool of resources, it gives you shared CPU resources, memory pools, workload balancing in terms of DRS, HA, and VM mobility in terms of vMotion. And this was really the one of the biggest operational revolutions in the enterprise compute. And that is the exact reason why VMware became the de facto. So now we talked about ESXi, we talked about vCenter server, we talked about clustering and resource pooling. So now let's bring everything together and let's understand how vSphere empowers the cloud. And in this architecture, if you see today, when enterprises deploy Kubernetes, AI platforms, databases, VDI, and enterprise application, all of these applications ultimately depends on compute. All of these business applications which might be running or which will be running in our workload domain of VCF ultimately depends on compute. Because underneath these workload domains, whatever you see that, we have a production domain, we have a development domain, we have an edge domain, we have a DR domain, we have a security domain. So we could have multiple workload domain, but underneath those workload domain, what we have is a vSphere, compute foundation of VCF, which empowers these these workloads. And this is the reason why I say vSphere is not just virtualization. vSphere is the compute foundation of VMware Cloud Foundation because it provides this vSphere layer provides compute virtualization. It provides storage, network, advanced security. It provides elasticity, high availability, operational efficiency. It provides one unified platform, built-in resiliency, and operational consistency. So just ask this question to yourself: without vSphere, without this compute foundational layer, did VCF exist? The answer is no, absolutely no. Without vSphere, without this compute foundational layer, VCF cannot exist. And this is where infrastructure evolution reaches to the next level. And that brings us to the unified cloud operations. Now, look at this architecture very carefully, guys. This architecture is no longer your traditional virtualization. This is unified cloud operations architecture. If you see at the center of this architecture, we have management domain. This management domain is controlling automation, lifecycle, monitoring, compliance, and your cloud operations. That's what management domain is doing it for us. Underneath, we have multiple workload domains which are consuming this compute clusters dynamically, what we have discussed in this entire episode. These workload domain consumes the compute clusters dynamically. And this is your software defined infrastructure at scale of enterprise. This is your software defined infrastructure at enterprise scale. And this is the reason why modern enterprises operate differently today compared to 15 years ago. Because of unified cloud operations, as you could see, it gives us a centralized visibility. It gives us intelligent AI driven insights, automated actions, and capacity optimization. Because of this software defined infrastructure at enterprise scale, I have an end to end visibility at the global scalable level. And then I do have policy driven automation orchestration. So as you could see that this is no longer your virtualization. This is no longer virtualization. This is cloud infrastructure operations. And VMware Cloud Foundation became the platform that unified all these layers together. That's what VCF is doing for us. So compute is the only one part of the story, guys. In the next episode, we move into the storage foundation of VCF. Because in this episode number 5, we have discussed about only one component of this entire VCF story, that is vSphere, a compute foundation of the VCF. In the next episode, we move into the storage foundation of VCF, and that is our vSAR. We will understand distributed storage, data resiliency, storage clustering, and cloud storage abstraction in our next. And most importantly, we will understand how VMware transform storage the same way virtualization transform compute. So we will understand the way we have seen the compute abstraction with vSphere. We'll see that how VMware transform storage with vSAN. And we will understand how VCF transforms into scalable cloud infrastructure. So before we close this episode, guys, let's summarize the architectural journey we completed today. So today you learned something extremely important. You learned something that virtualization was never only about running multiple VMs. It was about transforming infrastructure into software defined operations. And that is where we have discussed how virtualization transforms compute, how ESXi abstracts hardware, how vCenter centralizes operations, how clusters create a cloud scalability, and most importantly, we understood how vSphere empowers VMware Cloud Foundation. And this is exactly why at GoVMlab we always focus on architecture thinking because tools change, versions change, interfaces will change. But remember, guys, architectural understanding always create a long-term career growth. And that is what GoVM Lab is all about it, where we don't teach tools, but we focus on teaching architecture. So, guys, if this episode helped you think differently about infrastructure, helps you towards your VCF journey, then please like, share, and subscribe to GoVM Lab YouTube channel. And do join our GoVM Lab YouTube membership program, which has a bunch of more tutorials about vSphere, NSX, and the other product solutions. And keep continuing this VMware journey with GoVM Lab. So, see you guys in the next episode where we will talk about vSAN, the storage foundation of VCS. Thank you once again.